Good evening, everyone. Welcome to day 3, week 2 of our ML Bootcamp. I hope you all are having a great time exploring the fascinating world of machine learning. Today, we have an exciting topic lined up for you, multiple linear regression. Get ready to learn about multiple linear regression with Mr. Chaitanya Wankhede. Sit back, relax, and enjoy the enriching learning experience. Over to you, Chaitanya.
Hello, am I audible? Guys, can you acknowledge am I audible? Oh, thanks everyone. Thank you. So, hello everyone. I am Chaitanya Wankhede and I'm going to be the speaker for this week. And today we are going to talk about multiple linear regression. So, before moving on ahead, I'd like to see how much of new participants we have. So, can you guys just type in chat box that I'm new here? Okay. Oh, okay, so we don't have any new participants, I guess. So, Abhijit, you are new here. Okay. So, without further delay, let's start. Today, we are going to learn uh, multiple linear regression. So, let's just get the basics done firstly. Uh, this is the first time you are learning supervised learning algorithm, and you guys might be wondering why are we learning it thrice. So the reason is that the data science interviews they ask this question quite often many times. Okay, so that's why we have to just give a quick recap of it. So what are machine learning algorithms? Machine learning algorithms are uh, are those that help the computers to gain some insights of data. Now, what are supervised learning algorithms? In supervised learning algorithms, in the data set, we know both the questions and the answer, and the algorithm learns to map question to these answers. Now, as the question changes, the answer should also change, right? So, what we can infer from here that our questions are independent and our answers are dependent. Now, let's get a quick recap of the example taken by Atharva on first day. So, this was the example that he took. If I provide one as input, I get one as output. If I provide two as input, I get four as output. And furthermore, so what would be the output if I give 10 as input? Can you guys just type in quick? Yes, Atharva, you were already there. It's your example, okay? I want the others to type, those who have joined. Great. Okay, so I can see that there are few quick hits. Yes, you are right. The answer is 100, and the underlying equation of it was y is equals to x square. Now, now I would take this example to a quite next level. So what I'll do, I'll just add another input. So what if we have multiple input? If we give one and one as one and one as input, then we get two as output, and the further data set is available on screen. What would be the output if I provide four and three as input? Okay, Kavya and Sri Vishal Darshika. You guys are quite fast there. Yes, you are right. So the answer is 7, and the underlying equation was y is equals to x1 plus x2. Now, what would you guys be able to find any relation if I just keep on increasing the number of x and I would reach a certain point where you won't be able to calculate, right? The pen and paper wouldn't be any use of any use to you, right? So this is where our multiple linear regression comes in hand. Multiple linear regression would help us get insights of data and learn the data set in such a way that we will get a linear combination of all the inputs, right? This written over here, linear combination of all the inputs. X was our input, and the uh, equation followed by multiple linear regression is this equation. Don't worry about it if you don't get it, because we are going to see it further in detail. Now, what is learning linear regression trying to do? So, suppose we have a data set, you can see it on the screen. And can you guys again guess what is the output if I give 10 as input? Yes, 20, 20. Yeah. Yes, yes. So yes, it's 20. So what I'll do is I'll draw a graph of this data set over here. So you can see that these blue dots represent each of these data points over here. Now, what linear regression is trying to do, it's want to draw a line that will represent this data set. Now, if I give, as you can see, it's still 5 only up till here. Now, if I give 10 as input, so the graph will change and this line will provide us the output. Yes, here you can see that if I give 10 as input, I got 20 as output. This is what linear regression trying to do. Now, what are the basic requirements for linear regression? The data set should be linear. What do we mean by linearity? So, as we see that as questions change, our answers to changes. This dependence of a variable on another variable is called linearity, and the data point should be independent of each other. Now, suppose that if I give x1 as input and x2 as input, then the input given by x1 should not uh, conflict with x2. That's what this second point is trying to say. Now, how does linear regression work? So linear regression, what it wants to do, it's want to find the best fit line. So as you can see, these are our data points of it is a linear data set. Okay, so and this is our naive line drawn by us. So in our first iteration, we have drawn this line, and we draw a perpendicular from each data point on our line to get the distance of each data point to the line. Okay, so and we want to minimize this. So that's what linear regression tries to do. It just want to find a line that has minimum distance from every data point such that the line covers maximum data. Now you can see that this line is very much close to each and every data point and it has minimum distance from every data point. Did you guys got it till here? Great, great. Now, when to use linear regression? So, as we already saw, what were the basic requirements for linear regression? We wanted a linear data set. That's what stated in first point. Then we want a numeric output, which is not constrained to a specific range. So, if our output is constrained to a specific range, let's say 0 to 10, then that becomes a classification problem. But regression can give any value between minus infinity to plus infinity. It can give decimal answers also. That's where linear regression does. It gives a numerical output. So now, how does linear regression finds the best fit line? So before moving on to that part, let's just go through our cost function. And you guys have already seen this in the previous lecture. Were you guys there? Okay, Sri was there. Okay, Vishal, Sham, Pushkar was there. Vaidehi was there. Anuja was also there. Abhijit. Great, great, great. So you guys were there, and I hope it will make easy for me, but I have a different approach. So what the speaker of last week used was he started from top to bottom, but we are going to go from bottom to top. Okay, we are going to learn cost function using backward engineering. So let's suppose that we already created a model, and our model gives this predicted value y hat, and we already have this actual value in our data set. Okay, so how so mathematically how can we prove that these actual value and predicted value are the same? Can you guys guess? You just have to form an equation. How can we just make these two values equal? Did you guys got the question that I asked? If you uh, no Priyanshu, oh sorry, no Pushkar, uh, but that was a good guess by the way. So what I'll just do is I'll just subtract this value and make it equal to 0. Now, can you see that these two values are equal? Did everyone else got it? So this difference right here, the difference between the predicted value, the output given by our model, and the okay. Now, uh, what now what can we do? So let me just go to another. How can we calculate the error of the each data point? Uh, no, Janvi. Actually, we are deriving the cost function of linear regression. So it's not actual cost function. When we get to a slide, I'll tell you will get it when we got to other slide. Okay. So can you guys guess how can we calculate error of each data point? It's very easy. Okay. We have done it quite many times in our whole life. Just any wild guesses would be fine. Okay, so I guess it must be quite difficult. So what I'll sorry, your voice is can we use if condition? No, Sri, we won't be using it. What? No, 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 Sri. We are deriving a mathematical formula. Yes, Cabway, you are just quite there. Your answer is partially right. Um, what I'll just do, I'll just upgrade your answer. We will just take summation of each data point. Okay, so what we will do is we will take a summation of each and every error. So the m is the number of data points over in this equation. If you haven't got what is what has gone up until here, I can repeat. So does anybody want me to repeat how we got till here summation? Okay, so everyone got it, right? Okay, that's great. So uh so now okay. Thanks, Sri. So what I want to you guys to answer me this another question. Now suppose that this value, the error, can it ever be negative? Can a error ever be negative? Just for logic reasoning, I'm asking, can an error be ever be negative? Vishal, we are living in uh-huh. No, error can never be negative, guys. Yes, in this formula, it can be negative. Yes, if you are saying that in this formula, the error can be negative, but in real life, yes. So in this formula, the error can be negative, but we always want to get positive error, right? In real life, only positive error exists. So how can we convert this? If we get any negative error, how can we convert it into positive error? Can anyone guess? Forget about this equal to zero. Okay, till here. Yes, Ankit, you are right. Modulus would have been an answer, Visha, but sometimes it goes to complex numbers. So very good, Ankit. And so what we will do is we will just square this term, and the negative term would get converted into positive term. Now the problem with this formula is that when we have errors, let's say suppose 4, 25, and 36. Okay, so 4 is error calculated for question 1, 25 is error calculated for question 2, and 36 is the error calculated for question 3. Now, what would happen is that linear regression with just this amount of equation, it will just modify that 4 and keep on increasing that error. It will minimize the 32th error, and it will keep on increasing that 4th, the error we have got at question 1. So as you can see that the minimum error is getting maximized and the maximum error is getting minimized. So we don't want that, right? We want an overall minimum error to be present. So what we will do if we want to just generalize this error, okay? So we want to generalize this error so that the 4 gets always get modified from a value lower than itself, like 1 or 2. So how can we do that? Again, I'm going to ask for wild guesses over there because you guys are very active and I very well appreciate that. So can you guys guess how are we going to generalize this error? Okay, Ankit, I'll just repeat. Did you got the example I took, or you want me to? Okay. I'll repeat the example also. What I'll just do, I'll just annotate over here. Now, let's say, suppose we have a question one, and well, you are very right. So I'll just take this example first. So let's say that our question one, our example one got 4 as error, and our example two got 25 as error, and our example three got 36 as error. So what just this amount of equation will do, it will keep on increasing the minimum error, and it will keep on decreasing this maximum error. But we don't want that, right? We want a general error that is minimum. Did you guys got what we are trying to do? We want to just get a generalized error for each data point, so that the 4 gets modified. The 4 gets modified by a number greater than less than itself. Sorry, I just messed it up over here. So the 4 will always get modified from a number less than itself, like 1 or 2. Did you got it, Ankit and Sri? Okay, great. Just remove it and present it again. So we want to minimize that error, and we also want to generalize that error. So what we will do is we will just take an average, and this gives our cost function for linear regression, and this formula is also called as mean squared error. Now, there are many cost functions out there in the field of machine learning, and this one is the most prominently used in linear regression. Now, as I already said, we will be using backward engineering. Now, we want to go to the first step, right? Where we created our model. So, how are we going to calculate this y hat? So, I have a quick question for you guys. Do you guys remember what is the equation of a straight line? It's an easy question. I guess everyone can answer it. What is the equation of a straight line? No, Pushkar. The equation of a straight line. Yes. Yes. So I can see you guys are very well aware of it. Everyone learned it in school days. Y is equals to mx plus c. So what linear regression does, it just modifies this equation into a bigger equation like this. Now this equation is same as it, but only we had multiple x's. That's why we included this so many terms, and the c is got replaced by b, and the w here is called as weight, and b is called bias. So you guys get it right. So we have over here that big equation that we had over here. Did you guys got it till here? How we got to this equation? Okay, Sri, you have a very good doubt. So what is called bias? So bias is called the y-intercept of the equation, right? We have replaced C with B. That's why it's also called as y-intercept of equation. So now let's move on to how we are going to use that error, right? We have learned to calculate the error. Now we want to, right? We want to learn a best fit line. How are we going to learn it? So gradient descent, the most evolutionary algorithm ever in the field of machine learning or even in the field of AI. So gradient descent would help us our linear regression to minimize the error. Now, how it is going to do it? Well, what gradient descent wants to do is what we will do is we'll plot a 3D graph of our cost function. Okay, so this 3D graph, this soup bowl shaped graph is our cost function. So on x-axis we have w, on y-axis we have b, and on z-axis we have our cost function. And when we plot this graph, we got this soup bowl shaped cost function. Okay. Now, what gradient descent tells us that when we start creating our model, we start at point A. And what we want to do is keep on minimizing this cost function. So what we want to do is we want to travel from point A to point B. That's what gradient descent wants to do. It wants to go from point A to point B where our global optimal lies. Okay. At point B, we have the least error. You can see that the value of JW, our cost function is minimum, even lower than 100. Did you guys got the intuition what gradient descent is trying to do? Okay, Ankit got it. If you guys have any questions, you can ask. I'm free to answer. Okay, only Ankit got it. Should I? Oh, you want me to repeat? Okay, so guys, please keep on tapping me on the chat box so I can get where you guys are getting confused. Okay, so just keep on answering me. Now, how is gradient descent going to reach from point A to point B? Well, there's what gradient descent will do. We saw those weights and biases in our equation of linear regression, right? So, what gradient descent will do, it will try to modify those weight and biases in such a way that we would reach this point B. So you guys might be wondering what is this formula, right? We have partial derivative here. We have this alpha new variable over here. What is this trying to do, right? So don't worry about it. What we have done is we have written a block type readme file for you guys about this alpha, our weights, our biases on our GitHub. I'll show it after this section. Okay. So how are we going to calculate? So we will be looking at how are we going to calculate alpha, weights and biases. But this term I'll cover just now. So how are we going to take partial derivative of this cost function? So it turns out that the derivation of this partial derivative of cost function is quite difficult to understand. That's why I wrote the formula for it directly. So the formula for our partial derivative required to adjust our weights is this, and the partial derivative required to adjust our bias is this. Okay, so you don't need to worry about it. We use predefined functions to do that. Now just always remember that the weight get modified by a little bit formula. Just x data point is multiplied to the formula while modifying bias. We don't multiply it with x. Now, and another point to remember is that the weights will always be greater than bias. So, did you guys got it till here? Okay, Sri got it, Anuja got it, Soham got it, eh, Ankit also got it, Pushkar also got it, Vaidehi also got it. Okay, so thank you guys for the acknowledgement. Now, the most interesting part you guys have been waiting for. Let's dive into our code. So just open your collab. No, so first please go to your GitHub. Okay. Go to your GitHub account. Yes. So you might be seeing here that your branch is this much commit behind. Just go to sync fork and update branch. And please just acknowledge me that you have done this update branch. I guess everyone is doing it right now. I'll wait for a few minutes. So did everyone just updated their branch? Can I get a quick acknowledgement from everyone? Yes, yes. You need to click on the update branch. Okay, Ankit has done it. Piyush has done it. Cabwe has also done it. Shri has done it. Tanushri has also done. Pushkar is also done. So great. I'll also just update up my branch. And if you navigate to week 2 and day 1, I guess here's a README file for you guys uh, where we wrote some important points for you. So you guys were asking about weights and biases, what are their significance. You can go through this README file. Just go to week 2, day 1, and the README file will be open over there. Don't read it right now, okay? Just don't go over there. Now open your Colab and go to this GitHub section, files and file, open notebook and GitHub. There you find your ML Bootcamp folder, okay? And within that ML Bootcamp folder, you can find, where is it? Okay, multivariate linear regression and open it. So can you guys acknowledge that you opened your collab? I'll just write in the steps in the chat box. Uh, it's multivariate linear regression series. Can you say it? So I've written the steps. Those who haven't got it, now you guys might be seeing this type of interface over there. Just a second, okay, guys? Okay, so we are going to start now. Hope you are guys all there. So first of all, connect your runtime. I'll just zoom in quite a bit. Is this fine? Is this, are you guys able to see the screen and the code clearly? Can I get a quick acknowledgement? Okay, Piyush says yep. That's great. So we are going to first install a library. This, okay, run anyway. Then we are going to clone our repository in our collab. So it will be present over here. You can see that we have a ML Bootcamp folder over here. Then we are going to copy our files from that repository to our collab. So that we can use our plots for this week. Then we are going to import some of these libraries. Okay, you don't have to worry about it what these libraries do, as these are some of the commonly used. Then we are going to generate a random data set. So what today we are going to do is we are going to create a machine learning model for student rank prediction. Hope you guys are excited about it. So just run this cell. Okay. So I've already ran that cell, and let's visualize our data set. So we have study hours, math score, science score, English score, attendance percentage, and the rank of the student, right? We already, as I already told, that we also know the question and we also know the answer. And for After training a machine learning model, for a given question, we want to get the correct answer. So so after we train this model, when we give a certain amount of study hours, math score, science score, English score, and attendance percent, we will get the corresponding student rank. How cool is that, right? So first of all, we'll just get a quick overview of this data set using this dataset.describe. You don't need to modify these cells. We have already written it for you, wrote it for you. So what it tells is that study hours, we have 100 values over there. So as you can see, we have 100 rows. So we don't have any null values over here. And what is the maximum value in these columns, and a standard deviation, minimum value, the mean value. That's great. This describe function allows you to get a overall insight of our data set. Now X here represents our questions. Okay, so first write questions, and Y are our answers. Now what we'll do is we will try to uh, plot a 3D graph representing these first three columns and student rank if it's possible, because it's very much in the higher dimension. You can see this data set would be in 1, 2, 3, 4, and 5. It's a 6-dimensional data set. We can't visualize it. Okay, so on x-axis we have math score, on y-axis we have study hours, and on z-axis we have attendance percentage. And you can also see some this index over here. Now can you guys guess where will the line will be present that will just best fit this data set? Can you guys guess just by looking at it? I hope you got the question what I asked just right now. Okay, so what I asked was that this is a 3D plot for our data set. On x-axis we have math score, on y-axis we have study hours, and on z-axis we have attendance percentage. Now, can you find a best fit line that will have the minimum distance from each of these data point? Can you guys guess it? Well, let me get straight to the point. It's very much impossible for anyone to do that without doing some of statistics. So we are going to we are going to start it here. So what I'll just do for your clarification. So we are going to first calculate the error. You remember this term was y hat, right? I'll just quickly modify it. What is here was minus hat. Oh, okay. Let it remain just like it is. So it was, this term was y hat and this was our y. So this is our predicted value and this is our actual value. So we are going to implement this error value. So how are we going to implement? So error. Now, first of all, what let just wait. So first of all, what we will do when we just simplify this equation looks like uh, x w into x, right? It's just summation of w into x, w0 into x0 that doesn't exist, and then w1 into x1 plus w2 into x2. So before summing that, we will just multiply it. So how are we going to do it? So what we will do firstly, to just get multiplication, and it will be np dot x and w. So what is this x? X is our data for a single example. And what is our w? W is our weight or model parameters weight. So we have computed still w into x. Now this equation is also incomplete. So it's like, so did you guys wrote this line? Did you guys wrote it? And did you guys got it what this line will compute? Just a quick acknowledgement. Okay, Cabway, don't run this cell. I too haven't ran it. This cell will give you an error. I've just wrote it for clarification. Okay. Yes, Janvi, you are right. It is going to multiply. So what we are calculating is W into X using this line. Okay. Now we have calculated this much of formula. Now W into X plus P, right? And this will go into brackets. So how are we going to do that? So we'll just add bias, right? And we'll just do multiplication plus P. Okay, so B is our bias and we are taking bias as input from the user. And this formula can also be written as add dot so this line is similar to these two lines. So we have calculated this formula, okay? So which means that we have calculated our y hat. Now we also want to subtract our y, our predicted value, actual value from this. So what we are going to do is we are going to subtract y from this. Okay. So subtract actual value, and it will be add bias minus y. Okay, okay. Sure, sure, sure. Thank you for the acknowledgement, Janvi. So did you guys got it till here? don't run this cell until I tell you. Okay, so just don't run this cell until I tell, and also don't write this formula. It's just for sake of clarification. So can you guys just acknowledgement that you got till here? Right. Okay, so Born to got it. Vaidehi, Siri also got it. Janvi also got it. Okay, so I guess okay, Jatin also got it. Pushkar also got it. Great, 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 guys. So now I'll just have to return this error. Okay, so subtractual value, and you can run this. Okay, now I have a shortcut for this line. So in Python, there is always a way to write less line of code. So I'm going to write that code only. W plus Q. So you guys might be wondering what I wrote right now, right? So this term it's present over here. Then plus B term we did it over here. Then we also got this subtracted value. So we computed till here. So it's similar, it's same as writing this value. And now we are going to run this cell. So can you guys just acknowledge me that you got till here? Well, great. Now we are going to make use of this computer. Let me just remove this cell. Okay. So we are going to make use of this error formula to calculate the cost function or simply our loss function. So you can see we are going to calculate the formula that you guys just brainstorm of quite a minutes ago. So you can see hashtag start code here section in this cell. So how are we going to calculate the error? So error can be calculated using this function, right? We just wrote it. So we can calculate error using com compute error and compute error text x. So it's x underscore I. Uh, okay, Sri, I'll just repeat it. So, did you got a compute error? Did you successfully wrote this function? Sri? Yes, now you can run. You just need to copy this in your cell and you can run that code. What I'll just do, I'll just copy this and paste in the chat box. Those who are unable to get, they can just copy it from this. So moving on to our cost function, we are going to calculate this formula that you guys just derived a few minutes ago. So error. So how are we going to calculate the error? So we also wrote a compute error. So it says that we use the compute error function that you just implemented above. So we are going to use it compute error and it will take xi. I. So what it will do, it will call this function and calculate error for each point, each of our example, because you can see that we are inside a for loop that's going to iterate over each and every example. So we are going to get error of each data point into our error variable. Now we are going to square it. So how are we going to square it? So it's very easy in Python. Error star 2. And so let me just give you a clarification of what we have computed till here. So compute error means we have calculated its value, okay, and then we squared the error, okay. So by squaring, we have calculated the uh, this much of the formula. Now we are going to sum over each example, and so it's already written over here. Total cost is equal to summation of total cost plus squared error. So we have calculated over here. Now what's remaining is we are going to multiply 1 by 2m. So how are we going to do that? It's very easy. It's going to be total cost uh, um, I guess that won't be an issue. If you get an error, you can just acknowledge in the chat box free. So this way, we calculate our cost function, and you can run this cell now. So guys, acknowledge me if you got it till here, and if you have any issues, just type it in the chat box. Okay, you got it. Gone through was also got it. Pushkar got it. Sri got it. Great guys. Jatin also got it. So I guess I'll move forward. Now we are going to calculate the gradient. You saw this big very big formula over there. So we are going to implement it now. Now the again we are going to use the compute error function, and what we are going to pass it as parameters is x of I of r, and w, and 3. So we are calculating error in this line. So we have what it will compute is plus 3, and so by writing this line, we have computed this much. So what we have done is we have calculated the error. Now what we will do is we will, I guess our example gets multiplied over here. So error into capital X. So this is this much part of it. And we are also going to append the error into this. No, Siri. Actually, we are passing small y as our parameter to our compute gradient function. So we are going to use small y over there. So let me just, okay, well, you got it. So guys, did you got it till here? If you guys got it till here, just acknowledge in the chat box.
यहाँ तो जावा दे बेटा पनौती गई
Okay, can you just tell me on which? Okay, Jatin wants me to repeat. So Jatin, should I repeat the whole function? Okay, the compute gradient. From what point do you want me to repeat? And Capri, can you also tell on what cell you are getting error? Ranger? There's nothing as Ranger over here, Jatin. Oh, range. Okay. Over here, you are asking about here. Okay, so first of all, we are going to calculate the error, and what this line is going to do, it is going to call the compute error function that we implemented above, and the computation it will do is this, and I'll also show you. It will compute the mathematical things done in this formula, and then so we have calculated here up till here. Now we are going to multiply it with the data point. So how are we going to multiply? Using this formula, and then we have calculated this. Okay, first line we have calculated, but we also want to calculate the second line. So for second line, we only need to sum over errors. So what we are going to do is sum over these errors. Now, did you got it? Okay, Cabway, what you can do is Cabway, what you can do is you can share a screenshot of the error you are getting on the group, and the team will get you get your error done. So I guess you guys got it till here. So should I move further? Okay, thank you for the acknowledgement. Just a second. Now, so we have calculated the gradients of our gradient descent. Now we are going to implement a gradient descent algorithm. So this code, it just does some pre-processing. It's not necessary. It is only for visualizing the graph that we are going to see in further. Now, how are we going to get this partial derivative of bias and partial derivative of weight? So the hint says that we have to use the gradient function. So we are going to use gradient function. And what are the parameters? And the parameters are capital X, I, W, P. So using this line, we calculate, we actually get this. Okay, so using that line, we calculate this much amount of the formula. Now we are it's remaining that Wj alpha over there. So let's implement that. W minus alpha into dj underscore dw. So by using this line, we have calculated this first line. Okay. Now we have to calculate the second line also, right? So we are going to implement it right now. It will be b minus alpha into into dk by dv. So done. We wrote a formula for performing gradient descent. Sorry, we wrote a code for performing gradient descent. So just run this cell and acknowledge me in the chat box that you have got it till here. Pushka did it. Sri also did it. Where are the others? Guys, are you facing any issue? Great, 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 great. Okay, okay. Thank you guys for the acknowledgement. So that's it. We implemented our linear regression and we are going to train our model now. So as you can see, after each and every iteration, our value of cost function kept on decreasing. So at first iteration, it was 6. Now after 90th iteration, it is 1.18 now, and you can run it again if you want to, but for the sake of visibility, we are going to first plot the graph. There you can see it's very big. Okay, sure, sure, sure. So you are asking about this line, okay? So what this line is going to compute, it is going to compute this. Okay, let me just use annotator for this. So using that line, we computed that this part and this part, okay? And we already wrote a function about the compute gradient function to calculate this formula, this part of the formula. Now did you got it? Okay, great. So as we can see, our loss curve, we have on x-axis number of iteration, and on y-axis we have our loss. So as you can see, as the number of iteration increased, the loss kept on decreasing. That was what gradient design trying to do. But what we can see is that after the 100th iteration, the the changes in the loss function becomes diminished, right? It's going to get a single straight line over here. So after some point, what this line tells that after some iteration, some point in future, the model will stop learning and we would have. So that's it. You guys did it. You guys implemented a student rank prediction model. Did you guys got till? Did you guys plot this curve right here? Did you guys get it? Oh, sure, sure. Of which function? Compute gradient or gradient descent? Guys, if you two have any error, just acknowledge me. I'll just show the code. Okay, so here it is. You just have to modify the code present within this segment. Start code here and end code here. Rest of the code is for okay, Capway, I'll just do it. No worries. So um so Capway, so what in this first function, what firstly we wanted to do was we wanted to calculate this y hat minus y value. So y hat, the equation of y hat was this. Now, so how are we going to compute it? So when we simplify this much amount of code, it is only written as x into w. So we by just doing this first, just writing this first line, we compute this much part of the formula. Then after writing this, we we completely wrote this formula. Then what we wanted to do, we wanted to subtract the our actual value from this equation. So how we did that was here. And finally, we calculated the error using this line. So, Gabby, did you got it, or did I went too fast? Okay, Gabby got it, and hope you are not getting any error in this section. Now let's move to the cost function implementation. So, what in this formula? So this part of code, so this part of formula, we already wrote a code for that, right? So what we are going to do is we are going to use this code in this formula by calling the compute error function that we implemented above. Okay. So using just this amount of line, we calculated this part of the formula. Then what we are going to do is we are going to square this. Okay. So we are going to square this formula. Sorry for the background noise, guys. So we are going to for calculate this much. Sorry. So we already calculated this using that line, and now we are going to square it. So how are we going to square it? We are just simply going to square the error, and then we want to compute the summation. So how are we going to sum sum over there? So this is the line that does that summation part, and the 1 by 2m we want to multiply it by 1 by 2m, right? So it can be simply done using this line. Now, Cabwe, did you got this too? Okay, great. Now we are going to implement the gradient, uh, calculate the gradient. So as you already saw that we calculated this error term in the function above, this compute error function. So we are going to again use it. So just for sake of clarification, I'm going to use that annotator tool. So just so we are going to calculate the term present inside this box. Now, how are we going to calculate it? I guess I'll just have to remove that. Yeah, wait a second. So for calculating this, we wrote this line, okay? So as you can see, I also wrote a comment that using this line, we are calculating this part of the formula. Then we want to multiply x to this term. Now, how are we going to multiply it? We are going to multiply it using this line of code, and up till here, till here, we implemented only the first formula. Okay, we only implemented the first formula. Now we also want to implement the second formula. So for second formula, we are going to do this, and that's it. That's how we computed our gradient. Gabby, did you got it? And now for gradient descent, we already calculated this formula above, and we are what we just need to do is multiply this formula with the alpha and subtract it from the weight. So how are we going to do that? So first of all, for calculating this part of formula, we are going to write this line of code, okay, the gradient function. We are going to call this gradient function. Then for doing this part of formula, wi minus alpha into the partial derivative, we are going to use this line of code. And that's it. I hope you got it, Capway, and I hope everyone else got it. Can you guys just acknowledge me that everyone else also got it? Okay. So using this cells, we start the training our model, and as you can see, for first iteration, our cost value of cost function was 6, and after 90th iteration, our cost function value is 1.18. So this is what gradient descent trying to do. It was trying to minimize the cost function. Now let's just, for the sake of clarification, we are going to plot the loss curve, or also termed as the cost function curve. So when we plot number of iteration against loss, we get this curve. So what this curve is trying to tell us that as the number of iteration increased, the cost function kept on decreasing. You can see that at initially at 0th iteration, the cost function started at 6, and after 100 or so 90th iteration, it came below 2. I am getting here error. Okay, so Sri, you can just post your screenshot of the error on the group. the team will look into your error. Okay. I hope you guys got the concept behind what was this plot trying to do. Now let's get to the submission part. Open your GitHub profile, go to the ML Bootcamp, your repository, go to week 2 and then day 1 and inside this submission folder. Okay, so I'll just write the navigation steps. To GitHub profile, open repository. So what you guys should do is go to your collab again and download the notebook as you already know and rename it with your name. So like this, okay, and save it. I'll show it again. Go to files, go to download and download it and rename it using your name like this and save it. So acknowledge me guys that you have downloaded your notebook and renamed it with your name. Okay, Piyush got it. Okay, Capway, no issues. If you if you get any further errors, what you can do is you can tag me on the group and I'll just try to solve your errors after the session. Okay, not right now. Just so guys, if you are still getting any errors in the code, what you can do is you can drop a screenshot of it on the uh, group and you can just tag me over there. So I hope you guys downloaded the file and renamed it as your with your name. Now go to your GitHub and inside this submission folder, click on add file and upload the files. Okay, so here's your files. Open it. And then commit your changes. Okay, Pushkar did it. Pushkar, you are quite fast right there. Abhijit also did it. Everyone else, can you just give me an acknowledgement that you uploaded your file and committed your changes? Okay, Soham also did it. Where are the others? Those who have got errors, you can also submit the file and you can rewrite the file again. Okay, Vaidehi also did it. Bontu also did it. Great, great, great. And just commit your changes. I'm also going to commit my changes. Then after committing your changes, you are going to see this one commit ahead line. Just click on that and create a pull request. And in this line, you are going to write submission and your name. Okay, okay, okay. So I'll just go back and write it again. So can you see this one commit ahead? Want to just click on it and create pull request. Are you able to see this button right here? Okay. After clicking over here, you can see this create pull request button. Bonto, did you got it? Can you see this create pull request button on your computer? Okay, so Bonto, I guess you haven't uploaded your file. So what you should do is go to this week 2 folder, okay, week 2 folder, and inside it, go to day 1 folder, and inside day 1 folder, go to submission folder, and inside that, go to add file and upload the file. You can, the file that you downloaded, the collab file that you downloaded with your name, and just open it over there. And then commit your changes. You are going to see that one commit ahead line over on your repository. Bonto, did you got it? Everyone else just okay. So Bonto, what you can do is you can drop an SS of the screen on the group, and the team will look after it. Okay. So guys, just create a pull request. You guys have already done it, I guess. I'm the only one remaining. Oh, and create a pull request over there. And that's it for today's session. I hope you guys enjoyed it. And tomorrow we are going to learn decision tree. I hope you guys are excited for tomorrow's session. Guys, you can leave the session, and I hope you guys will be there present over tomorrow. See you there. Bye bye.